ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಂಡರ್ ದ ಇಂಟೆಗ್ರಲ್ಸ್ ಇನ್ ಕಾನ್ಸೆಪ್ಟ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಸೊ ಯೂಶುವಲಿ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮತ್ತು ಇಂಟೆಗ್ರೇಷನ್ ಟೂ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಆಫ್ ಕ್ಯಾಲ್ಕುಲಸ್ ಅವೆರಡನ್ನು ಸೆಪ್ರೇಟಾಗಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇರ್ತೀವಿ. ಕೆಲವು ಸಲ ಅಂಡರ್ ಇಂಟೆಗ್ರಲ್ ಸೈನ್ ಫಂಕ್ಷನನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಬೇಕಾದಂಥ ಸಂದರ್ಭ ಬರುತ್ತೆ. ಅಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಈ ಕಾನ್ಸೆಪ್ಟನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಂಡರ್ ದ ಇಂಟೆಗ್ರಲ್ ಸೈನ್ ಕಾನ್ಸೆಪ್ಟನ್ನು ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಫಂಕ್ಷನ್ಸ್ ಯಾವ ರೀತಿ ಇರುತ್ತೆ ಅಂತಂದರೆ, ಸೇ ಫೈ ಆಫ್ ಆಲ್ಫಾ ಇಟ್ಸ್ ಅ ಫಂಕ್ಷನ್ ಇನ್ ಆಲ್ಫಾ, ಬಟ್ ಇಟ್ ಈಸ್ ಡಿಫೈನ್ಡ್ ಅಂಡರ್ ಇಂಟೆಗ್ರಲ್ ಸೈನ್. ಇಂಟೆಗ್ರಲ್ a to b say f of x comma alpha dx. This is actually the particular case. So general case ಅನ್ನು ತಗೊಂಡ್ರೆ even these limits should be functions. These limits should be functions of the other variable, say x. Now, how to deal with these functions? How to find the derivative of such functions? If the function is given in explicit form, say for example, say phi of alpha equal to alpha square plus 1 or phi of alpha equal to sin alpha. So if it is defined like this, then you can find its derivative. There is no issue in that. But phi of alpha equal to integral a to b f of x comma alpha dx. Here the function is defined with the integral sign. Then how to find the derivative in such cases? So that is a very important method in mathematics. Now how to find the derivative of such functions phi of alpha? For this we need to use Leibniz rule. For this we need to use Leibniz rule. Leibniz rule simply says we are not going for any proof or any concepts that is behind the scope of the syllabus. We just state the rule. We are not going to explain it, why that term is occurring. So we are not going for any other explanation. We are just stating the rule, and then using that rule we are going to solve problems. ಸೊ ಇಲ್ಲಿ ಲೆಬ್ನಿಡ್ಸ್ ರೂಲನ್ನು ಆ ರೂಲ್ ಹೇಗಿದೆ ಆ ರೀತಿ ಬರೀ ಸ್ಟೇಟ್ ಮಾಡಿ ಅದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಷ್ಟೇ. ಸೊ ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಟರ್ಮ್ ಏನಕ್ಕೆ ಬಂತು ಏನು ಇತ್ತು ಅನ್ನೋದನ್ನು ನಾವಿಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಕ್ಕೆ ಹೋಗ್ತಾ ಇಲ್ಲ. ಇಲ್ಲಿ ನಾವೇನಿದ್ರು ರೂಲ್ ಏನು ಮತ್ತು ಅದನ್ನು ಹೇಗೆ ಅಪ್ಲೈ ಮಾಡೋದು ಇದ್ರ ಬಗ್ಗೆ ಮಾತ್ರ ನೋಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಲೆಬ್ನಿಡ್ಸ್ ರೂಲ್ ಹೇಳೋದೇನಂತಂದರೆ, ಇಫ್ ಫೈ ಆಫ್ ಆಲ್ಫಾ ಈಕ್ವಲ್ ಟು integral a to b f of x comma alpha dx, then the derivative of phi of alpha, that is phi dash of alpha, will be under integral sign integral a to b partial derivative of f with respect to alpha dx. This is what Leibniz rule says. Now employing this rule we are going to solve problems. ಸೊ ಇದು ಲೆಬ್ನಿಡ್ಸ್ ರೂಲ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಇದನ್ನು ಬಳಸ್ಕೊಂಡು ನಾವು ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ವಿ ಅಷ್ಟೇ. ಸೊ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನು ಹೇಳುತ್ತೆ, ಇಫ್ ಫೈ ಆಫ್ ಆಲ್ಫಾ ಈಕ್ವಲ್ ಟು ಇಂಟಗ್ರಲ್ ಎ ಟು ಬಿ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಕಾಮ ಆಲ್ಫಾ ಡಿ ಎಕ್ಸ್, ದೆನ್ ಫೈ ಡ್ಯಾಶ್ ಆಫ್ ಆಲ್ಫಾ ವಿಲ್ ಬಿ ಇಂಟಗ್ರಲ್ ಎ ಟು ಬಿ ಪಾರ್ಷಿಯಲ್ ಡೆರಿವೇಟಿವ್ ಆಫ್ ಎಫ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಆಲ್ಫಾ ಡಿ ಎಕ್ಸ್. ಸೊ ವಾಟ್ ಎವರ್ ದಿ ಪ್ಯಾರಾಮೀಟರ್ ಯು ಹ್ಯಾವ್ ಹಿಯರ್, with respect to that parameter we need to differentiate partially. Now let us discuss problems. So first I'll consider a simple problem. Given integral 0 to pi dx divided by alpha minus cos x equal to pi by square root of alpha square minus 1, where alpha square is greater than or equal to, okay, it is strictly greater than 1. So the denominator is strictly positive, strictly greater than 1. Then using this hint we have to show that integral 0 to pi dx divided by alpha minus cos x whole square equal to pi alpha divided by alpha minus alpha square minus 1 whole power 3 by 2. So this is what we need to prove. So to solve problems here under this concept, two things we need to keep in our mind. One thing is, first we need to identify phi of alpha. First we need to identify phi of alpha, then apply Leibniz rule. One thing. And with Leibniz rule, we also need to use usual integration. Usual integration must be done with respect to x. Okay, we need to apply Leibniz rule and also we need to employ usual integration. So Leibniz rule ಅನ್ನು ಕೂಡ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಫೈ ಆಫ್ ಆಲ್ಫಾ ಐಡೆಂಟಿಫೈ ಮಾಡೋದು ತುಂಬ ಮುಖ್ಯ ಇಲ್ಲಿ. ಲೆಬ್ನಿಡ್ಸ್ ರೂಲ್ನು ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಅದೇ ರೀತಿ ಯೂಶುವಲ್ ಇಂಟಿಗ್ರೇಷನ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು. ಸೊ ಅದು ಆಯಾ ಪ್ರಾಬ್ಲಮ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಪ್ರತಿ ಪ್ರಾಬ್ಲಮಲ್ಲೂ ಕಾಮನ್ ಮೆಥಡ್ ಇದು, ಲೆಬ್ನಿಡ್ಸ್ ರೂಲ್ ಯೂಸ್ ಮಾಡಬೇಕು, ಯೂಶುವಲ್ ಇಂಟಿಗ್ರೇಷನ್. ಕೆಲವು ಸಲ ಅದು ಬೇಕಾಗದೇ ಇರ್ಬೋದು ಯೂಶುವಲ್ ಇಂಟಿಗ್ರೇಷನ್. ಆ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೋಡ್ತಾ ಹೋದಾಗೇ ಐಡಿಯಾ ಬರುತ್ತೆ. ಸೊಲ್ಯೂಷನ್. ಸೊ ಫಸ್ಟ್ ಐಡೆಂಟಿಫೈ ದಿ ಗಿವನ್ ಥಿಂಗ್. ಗಿವನ್ integral 0 to pi dx divided by alpha minus cos x equal to pi by square root of alpha square minus 1. So this is the given thing. So ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ alpha square greater than 1. ಇದು ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥದ್ದು. And we need to prove this thing. Okay, let us keep that in mind. That is our target. Now we need to apply Leibniz rule. Means first we need to identify phi of alpha. So usually integral sign ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಬೇಕು. ಇಂಟಿಗ್ರ್ಯಾಂಡ್ ಫಂಕ್ಷನ್ ಆಫ್ ಆಲ್ಫಾ ಆಗಿದೆಯಾ ನೋಡಬೇಕು. ಸೊ ಇಲ್ಲಿ ಆಲ್ಫಾ ಇದೆ, ಸೊ ಇಂಟಿಗ್ರ್ಯಾಂಡ್ ಇಸ್ ದ ಫಂಕ್ಷನ್ ಆಫ್ ಆಲ್ಫಾ. ಸೊ ದಿಸ್ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಆಸ್ ಫೈ ಆಫ್ ಆಲ್ಫಾ. ಲೆಟ್ ಫೈ ಆಫ್ ಆಲ್ಫಾ ಈಕ್ವಲ್ ಟು ಇಂಟೆಗ್ರಲ್ 0 ಟು ಪೈ ಡಿ ಎಕ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ, ಓಕೆ ಇದನ್ನು ಒಂದು ಕೆಲಸ ಮಾಡೋಣ, 1 ಬೈ ಆಲ್ಫಾ ಮೈನಸ್ ಕಾಸ್ ಎಕ್ಸ್ into dx ಅಂತ ಬರ್ಕೊಳ್ಳೋಣ. So this 1 by alpha minus cos x is nothing but f of x comma alpha. This is f. This is f of x comma alpha. So applying Leibniz rule, we get phi dash of alpha equal to, ನಾವೀಗ ಲೆಬ್ನಿಡ್ಸ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ phi dash of alpha equal to integral 0 to pi partial derivative of f we have to write. So partial derivative of 1 by alpha minus cos x. See, this is just like partial derivative, okay, derivative of 1 by x. What do you get if you differentiate 1 by x? You get minus 1 by x square. ಹೌದಾ, 1 by x ನ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಮೈನಸ್ 1 by x ಸ್ಕ್ವೇರ್ ಬರುತ್ತೆ. ಅಂದರೆ 1 ಬೈ ಫಂಕ್ಷನ್ ಏನೋ ಇದೆ ಅದನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ 1 ಮೈನಸ್ 1 ಡಿವೈಡೆಡ್ ಬೈ ಫಂಕ್ಷನ್ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಬರಬೇಕು. ಸೊ ದಿಸ್ ವಿಲ್ ಬಿ ಮೈನಸ್ ದಟ್ ಐ ವಿಲ್ ರೈಟ್ ಔಟ್ಸೈಡ್ 1 divided by function is alpha minus cos x whole square dx. So call this as equation 1. Call this as equation 1. Actually ನಮಗೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಏನು ಬೇಕಿತ್ತು ಅದು ಸಿಕ್ತು ಈಗ. ಸೊ ನೆಕ್ಸ್ಟ್ we have, say I have taken this as phi of alpha and these two are equal. So we have phi of alpha equal to pi divided by square root of alpha square minus 1. Since these two are equal, I can take phi of alpha equal to pi by square root of alpha square minus 1. So this I can write to have simpler notation, alpha square minus 1 whole power minus 1 by 2. Now differentiate it. You get phi dash of alpha equal to pi constant term into, see, x power n differentiate ಮಾಡಿದ್ರೆ n into x power n minus 1 ಅಲ್ವಾ. So here in place of n I have minus 1 by 2. Minus 1 by 2 into alpha square minus 1 whole power minus 1 by 2 plus 1. Okay, sorry, minus 1 it is. Yes, I forgot. as minus 1 it is. Now it will be minus, okay, forget one more step, into s derivative of this inner term 2 alpha, right? So 2 get cancelled, we remain with minus pi into alpha square minus 1 whole power minus 3 by 2. So we can write this as into alpha, right? Minus pi alpha divided by alpha square minus 1 whole power 3 by 2. Hence, if you take this as equation 2, from equation 1 and equation 2, we have minus integral 0 to pi 1 by alpha minus cos x whole square dx is equal to minus pi alpha divided by alpha square minus 1 whole power 3 by 2. So minus minus get cancelled. Finally, I got the result. So that completes first problem. So there is one more problem. See, this problem says, by employing the rule of differentiation under integral sign, by employing the rule of differentiation under integral sign to the integral 0 to 1 x power alpha dx, where alpha greater than minus 1, prove that integral 0 to 1 x power alpha log x dx is equal to minus 1 divided by alpha plus 1 whole square. Okay, first observe the statement carefully. You have to apply the rule of differentiation under integral sign to this function, and applying that concept to this, you have to establish this result. So in the problem statement, it is clearly given that you have to take phi of alpha to be integral 0 to 1 x power alpha dx. You have to take phi of alpha to be integral 0 to 1 x power alpha dx. Let us call this as equation 1. Now applying Leibniz rule, we get phi dash of alpha, applying Leibniz rule, we get phi dash of alpha equal to integral 0 to 1 partial derivative of x power alpha with respect to alpha dx. See, we have derivative of a power x to be a power x log a. So this is the variable is in power. Now again here variable is in power, so this rule I have to imply. So it will be integral 0 to 1 x power alpha log base alpha log x dx. So this is phi dash of alpha. Call this as equation 2. So ಇಲ್ಲಿ ಲೆಬ್ನಿಟ್ಸ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ. ನಾನು ಮುಂಚೆ ಹೇಳಿದಾಗೆ ಪ್ರತಿ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಯೂಶುವಲ್ ಆಗಿ ಲೆಬ್ನಿಟ್ಸ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಯೂಶುವಲ್ ಇಂಟಿಗ್ರೇಷನ್ ಅನ್ನು ಕೂಡ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಲೆಬ್ನಿಟ್ಸ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಾಯಿತು. Now we have, again I'll consider this phi of alpha equal to integral 0 to 1 x power alpha dx. If you integrate this, it will be x power alpha plus 1 divided by alpha plus 1 between the limits 0 and 1. Applying limits, it will be 1 by alpha plus 1. Now I want phi dash of alpha. Differentiating, you get phi dash of alpha equal to minus 1 by alpha plus 1 whole square. So this is equation 3. So from equation 2 and 3, I got integral 0 to 1 x power alpha log x dx equal to minus 1 by alpha plus 1 whole square. That's what I was supposed to prove. So ಇಲ್ಲಿ Leibniz rule apply ಮಾಡ್ತಾ ಇದೆ ಮತ್ತೆ usual integration apply ಮಾಡ್ತಿದ್ದೀವಿ ಅಷ್ಟೇ. We are doing nothing except these two. So I'll consider one more problem, problem number 3. By using the rule of differentiation under integral sign, by using the rule of differentiation under integral sign, evaluate the integral 0 to 1 x power alpha minus 1 divided by log x dx, where alpha is greater than or equal to 0. Solution. Okay. Now, if you look into the problem statement once again, by using the rule of differentiation under integral sign, evaluate this. Right. So we need to find the value of this integral. Obviously, this is a function of both alpha and x. Let phi of alpha to be integral 0 to 1 x power alpha minus 1 divided by log x dx. Now applying Leibniz rule, we'll be getting phi dash of alpha equal to integral 0 to 1. We need to differentiate with respect to alpha. So log x ಹಾಗೆ ಇರುತ್ತೆ ನ್ಯೂಮರೇಟರ್ಲಿ x power alpha into log x. x power alpha differentiate ಮಾಡಿದ್ರೆ ನಮಗೆ ಸಿಗೋದು x power alpha log x divided by log x into dx. So log x get cancel. So I got phi dash of alpha equal to integral 0 to 1 x power alpha dx. But actually I need the value of this integral. This is what? This is phi of alpha. So again I should come back. So find the value of this integral first. Integral 0 to 1 x power alpha dx, the value of that integral is x power alpha plus 1 divided by alpha plus 1. That should be evaluated between 0 and 1. So you get 1 by alpha plus 1. That is phi dash of alpha. So phi dash of alpha is 1 by alpha plus 1. Now integrate, because actually I want phi of alpha only. So integrating, I will be getting phi of alpha equal to log of 1 plus alpha plus some constant of integration. Now we need to find the value of this integral, value of this constant. Put alpha equal to 0. That is the only variable we have. Put alpha equal to 0. Then we get phi of 0 equal to log 1 plus c. What is log 1? 0. So you got phi of 0 equal to c. But from equation 1, look into equation 1 now. What is equation 1? Equation 1 is this. Okay, we have not called it. Call this as equation 1. So from this, if you put alpha equal to 0, illi alpha 0 anta tagondre x power 0 minus 1 by log x, it becomes, okay, ಬರೆಯೋಣ ಇಲ್ಲೇನೆ ತೊಂದರೆ ಇಲ್ಲ, phi of alpha equal to integral 0 to 1 x power alpha minus 1 by log x dx. So if you take alpha equal to 0, then we will be having phi of 0 equal to integral 0 to 1 x power 0 minus 1 divided by log x dx. That is 0, because all integrand will be 0. So we got phi of 0 equal to 0. Hence c equal to, that is phi of 0 equal to 0. Therefore phi of alpha equal to, which is nothing but integral 0 to 1 x power alpha minus 1 divided by log x dx is equal to log of alpha plus 1. That completes the solution. So with this, we have stated Leibniz rule and we have solved three simple problems on Leibniz rule.